The interview questions are not predictable. You collect your questions in your library and practice, but you should still expect the unexpected. Today, I'm going to introduce another coding interview question that requires you apply multiple data structures. The input is a file. It is a list of employees with employee ID, first name, last name, and report to ID. Output the file to show the hierarchy. Nobody to report to is at the top. This is a sample input file. Rob Choi's employee ID is 1. His report to ID is 6, which is Joseph Grant's employee ID. While Joseph Grant has nobody to report to, he is at the top. Other employees who report to Joseph Grant are Luis Lima and Moises Medina. Here is the sample output file. So the question asks you to read the input file and build a hierarchy. It looks similar to my last tutorial, process log with stack. But this time, the input data is in random order. The first question you ask yourself, or the interviewer will ask you is, what data structure you are going to use? Tree is a good data structure to reflect a hierarchy problem. Once the tree is built, it is easy to output the data with the traversal of its nodes. However, we cannot build the tree while we read the file because we don't have the whole picture who are the subordinates for each employee ID until the end of the file. We need a temporary data structure to hold the data while we read. The data structure that's easy to add and fetch data is a Hashmap. Therefore, the answer for the first question is we need two data structures, tree and Hashmap. Now let me briefly introduce these two data structures. First, Hashmap. Hashmap is a data structure that can map keys to values. The values are stored horizontally in the linked list. From the key, the correct value can be found. You can find information on how Hashmap works internally and how to override hashcode and equals function to avoid collision from many tutorials. Here, I will use the methods in Hashmap class provided by java.utl package. To use it, we need to import java.utl hashmap. The most used methods are put and get. Please note, Hashmap will not maintain the particular order, which is fine in our case. Tree is a structure representing the hierarchical relations of the nodes. It has one root, which has no parent. Each node can point to 0 or multiple other child nodes. The nodes contain the data such as integers, strings, or objects. Level is the number of paths from the root to the nodes. The level of the root itself is 0. The most thin trees are binary tree, in which each node has maximum 2 children, left node and right node. The class tree node holds the data and links to the child nodes. The basic operations on tree are insert, delete, search, and traversal. Very often, we use recursion for the implementation. I have introduced recursion programming before. Check out my tutorial, Clean Folder Recursively with the link below. This is a function to insert data recursively. This is a function of a pre-ordered tree traversal recursively. For our case, each node can have any number of children. For example, Joseph Grant has 3 subnodes, while Rob Chose has 2 subnodes. Recursion makes the implementation clean and compact. We will apply similar implementation to our hierarchy tree in this tutorial. We can divide the task into 3 steps. First, read the data from the input file and build a Hashmap. Second, build a hierarchy tree with recursion. Third, print the tree with recursion. Based on the format in the input file, we can define a class employee. It has ID, name, and report to ID, which is the employee ID of his or her boss. While reading the file, we store the new employee object in the Hashmap. As we know from the tree structure, each tree node has links to its children. So for each employee object, we will define an additional variable subordinates. It is a list of links to other subordinate employee objects. To get the subordinates for any employee, we will create a function with the search employee ID as input parameter. We go through all employees in the Hashmap, compare their report to ID with the search employee ID. If the report to ID is the same as the search ID, the associated employee is added to the subordinates list. The final subordinates list are stored as part of employee object. Now we build the tree. We know how to build the binary tree recursively. We can apply the same idea here. Next is to print tree. We use the same concept of pre-order traversal using recursion. Please note, when the node is root, the level is 0. When calling the subtree recursively, level add 1 each time. Here is the code. First, we define the employee class. We call it the employee node, treat it as a tree node. It has 4 variables: employee ID, name, report to ID, and the subordinates. We have 1 constructor for creating the employee object. There are getters and setters for each variables. In the report to hierarchy class, we define a hash map of the employees to hold all data from the input file. We also define a variable root as the root of the hierarchy tree. In the main function, the hash map is initialized first. Then 3 functions will be called in sequence. The first one is read data and create map. Inside the function, the data are read line by line and stored in the hash map. We have learned how to read file line by line in the previous tutorial, read and write file. Please check it out with the link below. If the data doesn't have report to ID, by default, it is top level. Its report to ID is 0. The next function is get subordinates by ID. This function will be called to get subordinates for any given employee ID. The for loop loops through all items in employee hash map and compiles the report to ID with the given ID. If they are the same, the employee ID will be put in the array list of the subordinates, which will be returned to the called function. Now we build the tree with recursion programming. It has 1 argument, local root. Calling from the main function, it is tree's root. Calling inside function, subordinate nodes is used as a root. Inside the function, get subordinates by ID is called to get the subordinates list of the employee. Then it calls itself recursively to create subtrees. The final function is print hierarchy tree. It has 2 arguments, local root and level. Calling from the main function, the arguments are root and level 0. The function prints data in the current node first, then print subordinates recursively. Let's run the code and check the result. The output file shows the hierarchy structure as we expected. Time complexity is n squared plus 2 times n. The time complexity of tree operation with recursion is n. Inside build hierarchy tree function, it also calls function to iterate through all employees in the hash map to form the subordinates. So the time complexity of build hierarchy tree is n squared, plus the time complexity for read file and print hierarchy tree. The total time complexity is n squared plus 2 times n. Space complexity is 5 times n. The space complexity of a hash map is n. The space complexity for tree operation with recursion is n because of the stack frames created for recursions, plus the strings and string arrays used for reading and passing data. So the total space complexity is 5 times n. That's it for build hierarchy tree. Please leave your comments below. Make sure to like, share, and subscribe. I'm Vivian. Thank you for watching. I will talk to you soon.